Hello viewers, in this class I would like to discuss on the numerics to obtain the equation of motion for a multi-degree of freedom system using the principle of dynamics. The principle of dynamics is nothing but the D'Alembert's principle. By applying the D'Alembert principle, we can have the equation of motion for the given system. So here in this system, we can see that the three masses are given. One end is fixed on the side, and three masses are connected with a stiffness K and 2K here, as it is given in the numeric. So the displacement x1, displacement x2 and x3 are seen for the respective masses. So after this, this is all the given data from the equation. From this particular data, we can apply the D'Alembert's principle to have the equation of motion for the given system. So to get that, we have to have the free body diagram of the each mass system. So how do you get that? As we have seen in the previous session, the free body diagram of this first mass. So this is the mass m. So for on this mass m, on the other side, on this part, the acceleration is there, m1 x1 double dot. Since the mass is not said as m1, m2, m3 like that, so the mass is m itself. That is what the given data in the numeric. And in this direction, the acceleration is there, and in the opposite to that, what we can have, this stiffness force and the two difference between the two displacement. So that is, we can write 2k minus x2 minus x1, right? So again, for this mass, there is one more stiffness is connected, that is k, that is acting in this direction because it is behind that mass, right? So which is k x1, we can say. X1 is the displacement for the particular mass, and the particular stiffness is connected to that one. This is the free body diagram of the first mass. And the second mass, if I take, this is the mass m, and in this direction again I have 2k, right? This is the same equation we can have, the 2k x2 minus x1, 2k x2 minus x1, and just I do write this in clear form, right? So in this direction, 2k x2 minus x1 we have. Again in this direction I have this acceleration with respect to mass into acceleration 2, since it is the second mass, the displacement is x2. Now again this mass means the second mass is connected to the previous one, and the next mass means it is in between the two masses on the either side. So for that, there is one more force which is expected to have in this direction, which is k times x3 minus x2, right? So this is the x3 minus x2. Now this is the free body diagram of second mass, free body diagram of the second mass, and this is the free body diagram of the first mass. In the similar way, I need to draw the free body diagram of the third mass system, which is this, right? So for this, if I draw the mass element, and I do not have any connection from this direction. In this direction we do not have any connection, only in this direction I do have, and here I do get acceleration, that is m3 x double dot, and here in this direction I can get this similar k times x3 minus x2, right? So this is the free body diagram of the third mass. Free body diagram of the third mass. So now in this way we can have the free body diagram of the each mass systems connected between the springs, and the spring constants are given, and that data will be given in the question. The mass will be given, and displacement x1, x2, x3 will be given. So once I do apply this free body diagram for the given system, now I would like to write the equation for each of the masses. For the free body diagram of 1, free body diagram of the 2, and third mass, I would like to write the equations. So now if I write it for the first mass, right? So first mass, if I write it, so what I can write again here, I would like to just recall that in this direction I would take the plus sign, and in this direction I will take the minus sign, right? Just to have the opposite poles or resisting forces for the mass. So now with respect to that, if I write the equations, so how I can write? So m x1 double dot is a one force which is acting on the mass m, and along with that k x1, right, and along with that minus 2k times x2 minus x1, right, which is equal to 0, which means the free body vibration, the force is not provided in the particular condition. So now I will rearrange the terms, and I do write in a simplification manner. So how I can write this is as it is m1 m x1 double dot plus k x1. So I will multiply this one. This is k x1. So I will multiply 2k x2 minus into minus plus 2k x1, which is equal to 0. So now k x1 is there, 2k x1 is there, this will be 3k x1, then I can write m x1 double dot plus 3k x1 minus 2k x2, which is equal to 0. So this is the first equation for the first mass. For the first mass, the equation of motion for this is m x1 double dot plus 3k x1 minus 2k x2. So I have written x1 x2 in this direction. So similarly again I will write it for the second mass system. So to write that second mass system, again I do consider the similar sign conventions. If I write that, it is m x2 double dot, right, and plus 2k x2 minus x1, and again I have minus k times x3 minus x2, which is equal to 0. So this is the first one, right? This is the first positive sign, and this is another one, and opposite to that this force is resisting or acting on it, on the mass. So again I do write this in a simplified manner. This will be as it is mx2 double dot plus 2k x2 minus 2k x1. I am just multiplying this 2k to the x2 and x1 minus k x3 minus into minus plus k x2, which is equal to 0, right? So now here I can see 2k x2 is there and k x2 is there, so it will be 3k x2 minus k x1 is there, and we do not have any other x1 value here, and minus k x3 is there, and again we do not have any x3 values here. So what I can write here now, simplified equation of this second mass, mx2 double dot plus 3k x2, right, and minus 2k x1 minus k x3, which is equal to 0. So I will just write x1, x2 and x3 like that, right. M x2 double dot minus 2k x1 plus 3k x2 minus k x3, which is equal to 0. So this is the third equation, second equation for the second mass. This is the second equation for the second mass. So now I will write the third equation, third part of the equation, means the mass 3. So for this mass 3, if I write, what I can write, I have only two forces here. Again I do consider the similar sign conventions, m x3 double dot, right. So that is the plus in the positive direction. Again I do have k x3 minus x2, which is equal to 0. Only I have two forces here. So I do write this in a simplified way, m x3 double dot plus k x3 minus k x2, which is equal to 0, right. So I will write this in a kx3 minus kx2 plus kx3, which is equal to 0. So this is the equation of motion for the third mass in the system, right. So now I am going to write the equation 1, equation 2 and equation 3 in a matrix form, because as they have asked us to write the equation of motion for the multi-degree of freedom system. So again, since there are three masses in the particular system, I would like to take all the three equations and to write in the equation of in the matrix form. So to write that, I do just consider these three equations, equation 1, equation 2 and equation 3. That is there in this form, particularly, that is m x double dot plus kx, which is equal to 0. We do not have any this acceleration part and stiffness part. We do not have any damping system here. The undamped condition is considered. So Cx dot will not be there, right. C value is 0, so Cx dot will be 0 here. So now by referring to this equation 1, equation 2 and equation 3, I would like to write the matrix form. To write that matrix form, I am going to refer this equation. I am going to write the matrix form here, referring this first equation. X1 m is associated with x1, so I will write here m, and here in this first equation I do not have the m x2, so however it will not be there. So m x3 it is not there in the first equation. Again in this second equation I do have with the x2, so x1 is 0 and here it is m and here it is 0. Again in the third equation I have with the x3, so for x1 it is 0, x2 it is 0 and x3 I have m. This is a mass matrix, right. So now the acceleration matrix is I can have the x1 double dot, x2 double dot and x3 double dot. If I multiply these equations, and I must get m x1 double dot and other two are 0, means x2 double dot and x3 double dot are 0 in the particular equation 1, and for similarly for second equation and third equation. Now I would like to write the stiffness matrix, this stiffness matrix. To write the stiffness matrix, I have to see the equation 1, 2 and 3 to write the x1, x2 and x3 coefficient values. right? So in this equation 1, the x1 is having the coefficient of 3k, so I will write 3k, and x2 has the coefficient of minus 2k, which is minus 2k here, and x3 we do not have, which is 0 in the first equation. Again I will consider this second equation. In this second equation, what I can write, x1 is having a minus 2k, x1 is minus 2k, and x2 is plus 3k, and x3 is minus k in the equation 2. Now I am referring the equation number 3. x1 is 0 here, I do not have x1 value, x1 is 0, and x2 is minus k, and x3 is plus k, right? Means this is x3 is having plus k and x2 is having minus k. This is particularly this is the stiffness matrix. So now I would like to write the displacement matrix, that is x1, x2 and x3. So that means if I write this particular equations in a matrix form, later if I multiply this mass matrix and the acceleration, stiffness matrix and the displacement, I must get the equation 1, equation 2 and equation 3. So this is the equation of motion for the given system, right? So equation of the motion for the given system using the principle of dynamics, that is D'Alembert's equation. So this is all about the first numeric. So this is the end of the particular equation. So similarly I would like to take another problem, problem number 2. I can take this problem number 2 over here. Problem number 2, again I will take the system to obtain the equation of motion for the multi-degree of freedom system. So in this I will slightly change the end conditions. So in the first equation we have got this cantilever type, we do not have any other system connected to the third mass. So now here I would like to take the similar case, which is connected over here, and stiffness is connected to the mass m. This is mass m, and again I have got one more stiffness which is connected to the second mass, and one more stiffener is connected to the third mass. This is m, and this mass is connected to one more end like this, right? And the stiffness values are given that in the equation k, this is 2k and this is k. So here a small change that I would like to take, that in the given data itself it is having only two masses. And now I will consider this end as a fixed end. Right? This end as a fixed end. Right. So now for this I do have the displacement. That is displacement in this direction as x1, means the only horizontal force displacement direction is seen, right? In this direction it is x2, right? And apart from that this is the total given system, and for this system we have to obtain the equation of motion for the multi-degree of freedom system. So again I do apply the principle of dynamics, and I do write the free body diagram of the particular equation. This question will be this much. Apart from this we do not have any other data. So for the free body diagram I must consider the equation is mass 1 and another mass 2. So now free body diagram for the mass 1 means this system. So this is the mass m, right? So as we will be having mass into acceleration, which is m1, In the other direction I do have 2k x2 minus x1, since it is x2 minus x1. And however here we have one more stiffness, that is k x1. This is the free body diagram of the first mass, and free body diagram of the second mass means for this one. So if I write for that, it is m again. We do not have m1 or m2 in the given data. So this is m x2 double dot, and here since it is a fixed end connection, it is acting here itself. We do not expect to have the displacement in the other direction because it is fixed end. Only the other, in this direction only we can expect the force to transfer or the reaction. In this direction it is fixed, we do not expect any forces in that direction. That is the only difference from the fixed and the free end. In the free end we have seen in the other direction, right? So it is k x2, and again in this direction it is nothing but this one, the 2k x2 minus x1. These are the two free body diagram of the equation given system. So now again what I do, I will write the equation for the first system and the second one. So to write that, I will consider this one. In this direction it is plus, in this direction it is minus. So m x1 double dot plus k x1, right, and this is 1 minus 2k times x2 minus x1, which is equal to 0. So now and I will just rearrange the terms. I am multiplying to the brackets, m x1 double dot plus k x1 minus 2k x2 minus into minus plus 2k x1, which is equal to 0, right. So now x2 are, this is x1, right, x2 is 1, x1 are 2, right. So m x1 double dot plus 3k x1 minus 2k x2, which is equal to 0, right. This is the first mass and the equation of motion for the first mass, equation 1. So similarly for the second mass, if I write, so that would be m x2 double dot plus k x2 plus 2k into x2 minus x1, which is equal to 0. So now m x2 double dot plus k x2 plus 2k x2 minus 2k x1 means I am multiplying this 2k to the bracket. So rewriting this equation for the mx2 for the x1, if I want to write, it is minus 2k x1 plus 3k x2. This 2k x2 plus 2k x2, it is 3k x2, which is equal to 0. So this is the second equation. This is the second equation for the mass m. So now by referring to these two equations, I must write the matrix form, equation in the matrix form. So how do I write? And that must be here in the form of m x double dot plus kx, which is equal to 0. So cx dot is 0 again, since the damping is not considered. In the matrix form, if I write, so how I can write? So since only there are two equations are there, so for the mass m x1 is there, and since in the equation 1 we do not have x2, and in the equation 2 x1 is not there, m is associated with x2. So the acceleration matrix x1 double dot and x2 double dot plus the stiffness matrix. If I write, what I can write, 3k for the x1, right, and for x2 it is minus 2k. Now in the equation it is x1 is minus 2k, for the x2 is it is plus 3k, minus 2k plus 3k, it is plus 3k, right, and the displacement matrix is x1 and x2, which is equal to 0. So this is the equation of motion written in the matrix form for the given system. So whenever it is been asked for the equation of motion for the multi-degree of freedom system, this would be the procedure to obtain the equation of motion in the matrix form. So later it can be analyzed for the different needs. So in the next session we will discuss some more numerics on the particular concept. Thank you.